Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to complete section 6.6 by looking at irrational and complex numbers and being able to take those types of solutions and work backwards to find our polynomial. One thing that you have to remember is that complex numbers as well as irrational numbers, they come in conjugate pairs. Meaning you cannot have one solution that contains an I without also having its conjugate. Same thing goes with square roots. You will never have one solution that's a square root. They come as pairs. Because of that rule, oftentimes when they state the solutions, they will only give you one of the imaginary solutions or one of the irrational solutions. So first, you have to be able to identify all of the roots by identifying where they left out a conjugate. So what that means, here we have 2 plus I. Well, 2 plus I cannot be a solution without 2 minus I. They come as a pair. You cannot have a positive square root of 3 without also having a negative square root of 3. And again, conjugates only occur with imaginary and square root terms. So this one does not have a conjugate pair. You only have conjugates with imaginaries and square roots. So now if I am working backwards, okay, like we did at the very beginning of 6.6, I have 1, 2, 3, 4, 5 solutions. So x equals 2 plus I, x equals its conjugate, 2 minus I, x equals a square root of 3 that they gave us. We had to identify the conjugate, which is a negative square root of 3, and x equals 1. Okay, remember step 2. You want all of these equations equal to 0. When you are looking at a complex number like this, yes, it has 2 parts, but this is technically one number. So I need to subtract it over as a group. So it would look like this. X minus the group, 2 plus I equals 0. Same thing here. You cannot separate this 2 minus I because it is a complex number. You minus it to the other side. X minus the group, 2 minus I equals 0. This is a positive square root of 3, so you minus it to the other side. This is a negative square root of 3, so I add it to the other side. Positive 1, to move it over with the x, I would have to minus 1. Now that they are all equal to 0, you take the non-zero side and you put it in parentheses so I can write this in factored form. So you will notice with these two, you have parentheses within parentheses, and that's totally okay. So I have x minus 2 plus I, x minus 2 minus I, x minus the square root of 3, x plus the square root of 3, and x minus 1. And that all equals 0. Okay, so it's the same steps. It just, this is a little bit more complex because we have imaginary numbers and square roots. When you multiply two groups together that contain the conjugates, so here, the conjugates are imaginary. If we do this correct, the i's will all cancel by the end. These are also conjugates. When I multiply those together, if we do it correct, the square roots should all cancel. So you want to make sure that even though you can really multiply in any order, you always want to multiply the conjugates together. So you would need to make sure that you multiply these two groups together. These two groups would need to be multiplied together. So let's go for it. Now, if I am doing the FOIL method, x times x is x squared. Now, when the x goes to the outside, remember a negative always goes with whatever's behind it. So this negative goes to these terms, and the x has to go to these two terms because I'm taking one term times two terms. So it looks like this. X times a negative 2 is negative 2x. X times a negative of a negative makes it a positive. X times I is ix. We have two variables. You always go in alphabetical order. Now, again, this negative has to go to both of those terms. I'm multiplying the middle two terms together. This is one term times two terms, so I'm distributing. X times negative 2 is negative 2x. X times negative I is negative ix. Last, negative times a negative is a positive. Now this has two terms and this has two terms. So what we're doing is we're actually doing the FOIL method within the FOIL method. This 2 goes with this 2. 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is 2i. I times negative I is negative I squared. So within that process, we had to distribute one term into two terms twice, and we had to FOIL within the FOIL. So it's kind of wild. These were conjugates though. If we did this correct, all of the i's should cancel. So check this out. Positive ix, negative ix cancels. Negative 2i, positive 2i cancels. Remember, I squared really has a value of negative 1. So this is negative of a negative 1, meaning it's really plus 1. So when I multiply these two together, I'm going to get whatever I end up with when I combine like terms here. So it's x squared, negative 2x and negative 2x is negative 4x. 4 plus 1 is 5. Now that's kind of crazy. You multiply these two crazy things together and you get x squared minus 4x plus 5. The same type of thing is going to happen when we go ahead and multiply these because they're conjugates. So the square root should cancel. X times x is x squared. X times a positive square root of 3 is x, square root of 3. Negative square root of 3 times x is negative x, square root of 3. Negative times a positive is a negative. Square root of 3 times the square root of 3 is the square root of 9, which is just 3. The middle two terms cancel because it's positive x squared to 3, negative x squared to 3. When I multiply those two things together, I end up with just x squared minus 3. Now don't forget, we still have this x minus 1. So I multiply those two together to get that trinomial. Those two together, I end up with a binomial. I still have my x minus 1. Remember, you can multiply in any order. These two binomials, I'm going to multiply them first because then I can FOIL. X squared times x is x cubed. X squared times negative 1 is negative 1x squared. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. I cannot combine any like terms here. It's already in a good order, so I'm done with those two. I expanded it to this. Now what I need to do is bring down this x squared minus 4x plus 5. I need to take the x squared into all of these terms, then the negative 4x into all of these terms, then the 5 needs to go into every single term. So x squared, I'm giving every single term 2 additional x's. So x cubed becomes x to the power of 5. X squared times negative x squared is negative x to the power of 4. X squared times negative 3x is negative 3x cubed. X squared times 3 is 3x squared. Done with the x squared. Now I multiply every number by negative 4 and I add one additional x. Negative 4x times x cubed is negative 4x to the power of 4. Negative 4x times negative x squared, negative times a negative is a positive. 1x and 2 x's make 3 x's. So I'd have positive 4x cubed. Negative 4 times negative 3 is a positive 12. X times x is x squared. Negative 4x times 3 is negative 12x. Done with that term. Now I need to bring the 5 into everything. 5 times x cubed is 5x cubed. 5 times negative x squared is negative 5x squared. 5 times negative 3x is negative 15x. 5 times 3 is 15. So now I am ready to state my final answer. Okay, 10 minutes in and we are here. Our polynomial function. You combine like terms, make sure that it is in the correct order. The highest exponent is a 5. That makes sense because at the beginning I had 1, 2, 3, 4, 5 solutions. So this has to be a 5th degree polynomial. This term has x to the power of 4. This term has x to the power of 4. So I need to combine those by adding the numbers in the front. Negative 1 and a negative 4 makes negative 5, x to the power of 4. This has a power of 3. This has a power of 3, and this term has a power of 3. Negative 3 plus 4 is 1. 1 plus 5 is 6. So it's 6x to the power of 3. This term has x squared. This term has x squared. This term has x squared. 3 plus 12 is 15. 15, 3 plus 12 is 15. 15 and a negative 5 is positive 10x squared. I saw this 15 and I kind of psyched myself out. Here we go. X's. This has an x and this has an x. Negative 12 and a negative 15 makes negative 27x plus 15. There is one problem, my friends. Not that it's necessarily difficult, but yes, this is a really big process. All the way back from, they don't even tell you all the solutions. You need to find the conjugate pairs. From there, you're working backwards. You want everything equal to 0, write it in factored form. Multiply all the conjugates together so you can cancel the i's, cancel the square roots. Finally, to get your final answer, you always need to combine the like terms and put it in the correct order. Okay. Obviously, I knew that one probably would not be enough, so we are going to do another one. Okay. If I look here, step 1, you need to identify the solutions. Okay, they're not going to give you all of them. Anything with an I or a square root must have a conjugate. If this is 2I, negative 2I also has to be an answer. If this is 1 plus a square root of 2, its conjugate is 1 minus the square root of 2. 3 is good to go. So again, I have 5 answers. X equals 2I, so x must also equal negative 2I. X equals 1 plus a square root of 2, so x must also equal 1 minus a square root of 2, and x equals 3. So you find all your solutions. Now we unsolve. You want every single equation to be equal to 0. So I need to take my positive 2i and you minus it to the other side, so that way it's equal to 0. This is a negative 2i, so I add 2i over, so it's equal to 0. Now this is one number, so you cannot separate it. You minus it over as a group. X minus the group, 1 plus the square root of 2 equals 0. Same thing here. You can't separate it, so you minus it over as a group to equal 0. This 3 I minus over to make it x minus 3 equals 0. Once everything is equal to 0, now you go ahead and write it in factored form. So x minus 2i is next to x plus 2i. X minus the group, 1 plus the square root of 2. X minus the group, 1 minus the square root of 2. X minus 3, it all equals 0. Now we get to start multiplying. Remember, you have to have your conjugates multiplied together. When I multiply these two things, because positive 2i and negative 2i are conjugates, all of the i's should cancel. So let's check that out. X times x is x squared. X times positive 2i is positive 2ix. Negative 2i times x is negative 2ix. Negative 2i times positive 2i is negative 4i squared. Positive 2ix, negative 2ix cancels. Anytime you have I squared, it is replaced with a negative 1. Negative 4 times negative 1 is a positive 4. So these two groups together make x squared plus 4. Now when I look at these two terms, again, because these are conjugates of one another, when I'm done, all of the square roots should cancel. X times x is x squared. Now this negative has to go in with the group as I distribute the x. X times negative 1 is negative x. X times negative of a negative is positive. X times the square root of 2 is x squared to 2. Now when I go to the inside, it's one term times two terms. So I'm distributing, but you have to remember that that negative always goes with what's behind it. So x times a negative 1 is a negative x. X times a negative square root of 2 is a negative x square root of 2. Negative times a negative equals a positive. Now I'm multiplying these two terms together. Okay, so I have to FOIL within the FOIL. 1 goes with 1. 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. Then I have negative or positive square root of 2 times 1 is positive square root of 2. Positive square root of 2 times negative square root of 2 is negative square root of 4, which is 2. Because these were conjugates, all of the square roots should cancel. Positive x square root of 2, negative x square root of 2. Negative square root of 2, positive square root of 2. So I'm going to go right next to this group. X squared, negative x and negative x make negative 2x. 1 and a negative 2. 1 minus 2 is negative 1. So notice I multiplied all of that craziness and I ended up with this because they were conjugates. We can't forget we still have x minus 3. Now you can multiply in any order you want. So when I see 2 terms by 2 terms, I instantly want to go ahead and FOIL those. So if I have x squared plus 4 and x minus 3, I'm going to multiply those together. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. 4 times x is 4x. 4 times negative 3 is negative 12. So I multiplied those two together and I got this group. So finally, I take these two polynomials and you multiply them together. So x squared minus 2x minus 1 has to go with x cubed minus 3x squared plus 4x minus 12. First, we bring an x squared into every term, which means you just add 2 x's. So this had 3 x's. If I add 2 more, I have 5. Minus 3, this had 2 x's. When I give it 2 more, now it has 4. Plus 4, this had 1x. If I give it 2 more, now it has 3. Minus, this negative 12 did not have any x's, so now it has 2. So I'm done with the x squared. Now I take negative 2x, and I have to bring it into everything. Negative 2 times an unwritten 1 is negative 2. 1x and 3x's make 4x's. Negative 2 times negative 3 is a positive 6. 1x and 2x's make 3x's. Negative 2 times positive 4 is negative 8. This has an x and this has an x, so together there's 2. Negative 2x times negative 12. Negative 2 times negative 12 is 24. This has an x, this does not, so together it's 1. So I'm done with that term. Now I multiply every term by negative 1. Negative 1 times x cubed is negative x cubed. Negative times a negative is a positive 3x squared. Negative 1 times 4x is negative 4x. Negative times a negative makes it a positive 12. So we have all of these terms that are going to be combined to get our final answer. So our polynomial, the highest exponent is a 5. And again, that's because at the beginning we had 1, 2, 3, 4, 5 solutions. Because we had 5 solutions, you need a 5th degree polynomial. Okay, so I have that. This has a power of 4. This term has a power of 4. So you combine them by adding the numbers in the front. Negative 3 plus a negative 2 is negative 5, x to the power of 4. Done with those. This term has a power of 3. This term has a power of 3. So does this term. So we add the numbers in the front. 4 plus 6 is 10. 10 plus a negative 1 is 9x cubed. X squared. This has 2 x's. This has 2 x's. So does this. Negative 12 plus a negative 8, that makes negative 20. Negative 20 plus 3 is a negative 17 x squareds. This has an x, this has an x. Positive 24 and a negative 4, that's positive 20x plus 12. This is the polynomial function where if we were going forwards and I said, hey, find the 5 answers, your answers would be plus or minus 2i, 1 plus or minus the square root of 2, and 3. Your assignment today is to try 3 of these. I know it's pretty intense, but the sooner you dive right in and give it a shot, the quicker you'll understand. Hope you enjoyed learning this concept today, and I'll talk to you soon.